Hello everybody, I'm just going to make this video not to really focus on why the triangle inequality works, but I'm just going to work on a couple ways to deal with how it works. So what I'd like to do is just kind of pose a few examples to you, but the triangle inequality basically says that the sum of any two side lengths must be greater than the third side length. So for example, if I just kind of pick some numbers here, like, I don't know, 4, 8, 10, right? And I want to test and see if this, triangle inequality works. Basically, no matter which two sides I pick, right? So if I use 4 and 8, that sum should be greater than the third side. Now, if that is not true, then that means this triangle or that situation cannot be drawn. The triangle cannot exist. So there's this is more of a formal way to describe it, but I'm just going to jump into some of the examples down below. So for example, if two sides of a triangle are 17 and 48, right? This extension of the triangle inequality basically says the following. If you know two sides of a triangle, which we do, then the third side can be anywhere between its sum and difference. So for example, I'm going to take these two numbers, I'm going to subtract them. I'm going to have 48 minus 17, which is 31, right? I'm going to then take these two numbers and I'm going to add them. 48 plus 17 is going to give us, what's that, 65? Yeah, right? So then basically that means I'm going to use S for the length of the third side, right? I'm going to use S for the third side. So basically that third side has to be greater than 31 and less than 48. All right, again, this video is just going to talk to you about how to use the triangle inequality. All right, the second one says, is a triangle able to be drawn with side lengths of 3, 12, and 16? Now, what I'm going to do is I'm going to start here and I'm going to say, well, I know that 12 plus 16 is greater than that third side. So far, so good. Then I'm going to say that 16 plus 3 is 19, also greater than that third side. However, 3 plus 12 is 15. So that is not greater than the other side. So if I just go back to the very top here, if a triangle is able to be drawn, any two side lengths you pick should be greater than the third side. So then this answer would be no. This is not possible to exist or not possible to be drawn. All right, and then finally, which of the following sets of numbers could represent a triangle? So if you want to pause the video right now, you can test each of these out. But I'm just going to basically disprove one of them and then show you what the final answer would be. So if you take a look down here, I'm going to say that right here, 5 plus 17 is 22. That is not greater than the third side. So that means this one, no good. If you try the other two to the left, they also do not work. So that leaves us with this final choice because 15 plus 22 is 37. All right, and in any other combination you try will give you the sum of two sides greater than the third. Alrighty, that's pretty much just how to use the triangle inequality. And I'd like to skip over to our second of 3 ideas for today. The other idea is something that you have seen in Algebra 1. It's simplifying radicals. Now we're going to try to simplify these radicals completely. So what I'm going to do is just go through again how, but then in class, we will, kind of dive into other possible strategies. But I'm going to start off with what I think is the easiest one, right? I should not have to go through any other means of simplifying this because we should know the square root of 36 is just 6, right? So sometimes a square root will simplify to a whole number. Next, I'm going to go to 24, okay? 24, I'm just going to zoom in here, right? So when we're simplifying radicals, we basically want to break them up into their multiples. So right now I know that 1 times 24 equals 24. Same with 2 times 12, 3 times 8. But what I want to do here is I want to choose 4 times 6. Okay, now I'm putting 4 in blue for a very good reason because that's a perfect square. That's what we want. So the square root of 4 is 2. And if you notice, I'm crossing off the square root symbol so I don't write it anymore. Once you take the square root, that symbol is gone. Alrighty? So our final answer here would be 2 radical 6. All right, actually, I'm going to leave that circled. Let's see. Okay, so now here's what I'm going to do. I'm going to head over here to radical 50. In most cases, guys, there's a long way to do things, and then there's a short way to do things. What I'm going to do right now is the long way, but then I'm going to delete it, and I'm going to show you the shortest way. So if I take radical 50, and I break it up into 5 times 10. Now, I know there's a better way to do this, but neither of these are a perfect square. So what I'm going to do is I'm going to leave radical 5 there, but then I'm going to split up radical 10, should be multiplying, into what's 10, right? 5 times 2. And here's where I want you to notice something special, right? I have one radical times the same radical. So radical 5 times radical 5 is the square root of 25, okay? That's why I'm going to go back here and I'm going to delete this. I think the best way to have done this would have been start with the perfect square, right? So basically, I should have done radical 25 times radical 2, right? Now, square root of 25 is just 5, and my final solution, or my simplified radical, will be 5 radical 2, all right? Now, in your calculators, you can type in the square root of 50, and that would give us, an approximated decimal. So this 5 radical 2 is the exact answer, right? So I just want you to notice that's the difference, right? This would be left exact and simplified, whereas if I just take my calculator and take the square root of 50, it's approximately 7.0710, et cetera, et cetera. So if I was rounding to the nearest tenths, this would be, I'd look to the next number, this would be 7.1. All right, let's just try one more of these. Maybe one that's a little bit more challenging. I don't know. Let's go to 175. So if I go to 175, sure, I can divide by 5. That might help. But I don't know, just a suggestion to you, whenever you see numbers that end in 25, 50, or 75 like this one, we should be able to divide that by 25. Like if you think about this as $1.75, I could break this up into quarters, like coins. All right, so let's see. How many quarters are in $1.75? Well, that should be 7. Alrighty, so our simplified final answer here will be 5 root 7. Okay, and then the approximate decimal, rounded to the nearest tenth, would be, if you type this in your calculator, you'll see where I'm getting this, right? 13.2. So approximate is 13.2, exact is 5 radical 7. All right, now finally, the last part of this video, we want to now kind of take some of the things we talked about with triangles, also some of the radical things that we just discussed, and we want to try to use the Pythagorean Theorem. Now, Pythagorean Theorem only works for right triangles, so we should be good with these 3 examples. Now, I'm not going to go through all of them, but I am going to go through probably like 1.5. So for example, the legs are always A and B. The hypotenuse, which is always across from the 90 degrees, will be our C. Okay, so what I'm going to do is I'm going to set this up as 3 squared plus 5 squared equals C squared. 3 squared is 9. 5 squared is 25. 25 plus 9 is 34, right? We take the square root, and then therefore C is radical 34. Now, after what we just did above, we should ask ourselves, can we simplify this radical? And if you take the time and try to split this up, really the only things that would work would be 1 and 34 and 2 and 17. None of those are really going to help us out to simplify the perfect squares, so that is our exact answer. If you wanted the approximate, then you type in your calculator. Okay, I'm going to head down to this last one because it's, some students look at that and say, oh, this is going to be tough. It's actually not too bad, okay? So I'd like us to set this up. Now be careful, A, B, C. So they actually did give us the hypotenuse here. So what I'm going to say here is I have, now be careful, always use parentheses, 2 radical 14 squared plus B squared equals c squared. Oh, excuse me. Yeah, equals 9 squared because they did give us the c. All right, now I'm going to do the easy parts here. I'm going to carry down the b squared, right? I'm going to square the 9, which is 81. But here's the tricky part, right? We have two things inside here that we're squaring. So what I'd like you to do is make sure that you're squaring both parts, okay? So the first part, let me go back here, is 2 squared. That's going to give us, that's going to give us 4. And then we're going to have radical 14 squared. But guys, the square root and the square cancel out, leaving just 14, right? So now what we're going to do is multiply 4 times 14, which is 56, plus b squared equals 81. And then once I subtract my 56 from both sides, it actually works out nicely, right? We get 25 square root, which means b was 5. All right, guys, so hopefully me walking through some of these examples here today will help you out. You should fill these out on your notes and then use these for your homework. All right, thank you.